Good morning. Today we are going to discuss arithmetic progression. For that, first we are going to study the sequence. A sequence is nothing but a term arranged in a definite order. So, what is meant by definite order? You maybe think that your natural number system, whole number system, integer. You know that 0, 1, 2, 3. We have some order. And also minus 1, minus 2, minus 3 and so on. So this is also the order. So we are not write 0 after 100, then 50, 30. Like that we are not arranged the particular terms. So now the sequence is arranged the terms. This is the first term, and the second term, and the third term, and the fourth term. It may be in any form 0, 1, 2, 3, 4, 5 and 6, so on. So like that a sequence is arranged in a definite order. In that order we can mention the terms, 5th term, 6th term, 7th term, like that. Okay. Now think about this sequence. In that sequence, suppose the numbers 10, 25, 30, 35, 50 and so on, some number. So here the last number, suppose 50, means this one is finite sequence. Sequence only I am just introduced 10, 25, 30, 35 and 50. And the same way 1, 2, 3, 4, 5, 6 and so on. We know that after that also we have number or 10, 20, 30, 40, 50 and so on. Such type of sequence is called infinite sequence. Such type of sequence is called infinite sequence. Suppose you may be think that first number we want to tell, second number we want to tell, right? For that first number here you can tell. The same way you studied integers. Here 0, 1, 2, 3 and so on. Minus 1, minus 2, minus 3 and so on. Here not possible to tell the first number. Here first number you can write, first number you can write, first number you can write. Here first number not possible to write. So in a finite sequence, we have first number, middle number, last number and all. The infinite sequence also we have first number only. There is no last number. Here you have last number, there is no last number. And it may be no first number, no last number. Such type of sequence is called. In the particular case of the sequence is arithmetic progression. So now we are going to concentrate only the arithmetic progress. The arithmetic progress is simply called AP. Simple form of this arithmetic progress is AP. When the sequence is called AP, means a sequence arranged in a definite order where the sequence is said to be AP. A sequence is said to be arithmetic progress if and only if. The meaning if and only if it arranged in a definite order. That's why it's called a sequence. In that sequence we need to tell the arithmetic progress. What is meant by if and only if? This condition is satisfied for your answer also. So that is the difference of any preceding terms are always constant. The difference between the preceding terms are constant. So what is meant by this meaning? You have on AB preceding terms, suppose 5, 10, 15, 20 and so on. Now sequence it may be in any order, but in arithmetic progress a sequence should be AB if and only the difference between any preceding term. The difference means this is the preceding terms. The difference is here 5. Only difference here 5. 10 minus 5, 5. Here 15 minus 10, 5. Here 20 minus 15, 5. So it's constant. Constant means not going to change. Means we can tell it's a arithmetic progress. In our book, you may be studying different type of definition of AP. This is also one of the definition. Right? Now in this AP, we need to give our examples, and before that the general term. Already we studied that AP should be first term. We need first term, so second term, third term like that. So general term, if A is the first number, first term, and D means difference. The difference we are going to tell common difference. Then AP. That is arithmetic progress general form is A, A plus D, A plus D plus D. Once again D added, so 2 times of D. That's why we can write A times 2 times of D. And A plus this one 2D plus D, 3D and so on. So this is what first term, second term, third term, fourth term like that. You may write your last term also. Last term how to write by using your arithmetic progress. So this thing also we can write. Here we are going to study that example. Suppose this one is up to dot 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 dot. So it's one infinite term. Suppose you have last term means it's one called finite term. So now think about this one A. The first term, that is A1, A2, A3, A4 and so on. Similarly you can write A5. A5 is nothing but A plus 4D and so on. Right. Here you just think about A plus D. Here second term, so A plus D. I am going to write one number. Here think about 2 of our third term. Third term means here 2D, no. I am going to write using 3. Here I am going to write using 2. 2 minus 1 into D. Here A plus 3 minus 1 into D. That is 2. Similarly here A plus fourth term. So 4 minus 1 into D. So means here we have A plus 100D. How can I write? A plus 100 minus 1 into D. 101 minus D. Okay, minus 1 into D. So A plus 100D. So 100 given. Now just think about number 100, here 101. So last term we need to write. So first term, second term, third term, fourth term. So nth term. First term, second term here 2, third term here 3, fourth term here 4. So nth term means a plus instead of number n minus 1 into 3. This is the last term. So don't bother about this one. We can study this. So simple form of AP, a comma a plus d, a plus 2d, a plus 3d, a plus 4d and so on. So what is meant by a and d and last term? This is only we are going to study. If we have the last term, we can tell first term this one, last term this one, like that. So example, suppose 3, 6, 9, 12 and so on. Here up to dot 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 dot. Instead of that you have 300. Means it's a finite sequence, finite arithmetic progress. First term, last term. Right. Here what is the value of A? So that is A equal to first term 3 and D, it's an AP, it's given. So 6 minus 3, so 3, 9 minus 6, 3, 12 minus 9, so answer 3. So now AP is given. Similarly, not only the thing, here just value increasing, so increasing sequence or increasing AP. Okay, the same way, suppose minus 10, minus 12, minus 14, minus 16 and so on. No last term, so it's one infinite AP. So here first term A equal to minus 10 and D equal to difference minus 12, then minus of minus 10. This is the meaning. So minus 12 plus 10, that is minus 2. So if you have a D is negative, so you think that no, it's decreasing. So it's decreasing. Like that sequence AP also there. The same way, suppose another example, you may think that 100, 99, 98, 97 and so on up to 0. So first number 100, last number 0. In that 100, A, this one last term, A plus n minus 1 into 2. Okay. Here A equal to 100 and D equal to 99 minus 100, that is minus 1. Similarly 98 minus 99 minus 1. So this is also decreasing. Okay. Now, since using a D, D is positive, so increasing. D is negative, so decreasing. Okay. Suppose the number 5, 5, 5 and so on. There is no change. So what that is A equal to 5 and D equal to 5 minus 5, that is 0. Now the common difference is 0. So using this we can tell this one is a constant AP. Decreasing AP, increasing AP, constant AP, constant sequence, like that constant AP. So think about the terms, whether it may be increase, decrease or no change. So these all are some examples. You may across many examples and you may think that whether it should be changed at any one number or not. If it change the difference, D change at any place means definitely it's not a arithmetic progress. Suppose A equal to 7 and D equal to 3. Now just we need to write AP. A equal to 7, no? So first number 7. D equal to 3 positive. So that we can write 10, 13, 16, 19, 22 and so on. If A equal to 10, D equal to minus 2. First number 10. Minus 2, we need to decrease. So 10 minus 2, 8, then 6, then 4, then 2, then 0. 0 minus 2, minus 2, minus 4, minus 6 and so on. Similarly. If A equal to minus 10, then D equal to minus 2. That is minus 10. Still we need to decrease. So how to write the decrease? We need to add minus 10 plus of minus 2. That is minus 10 minus 12. That is minus 12. It's minus 12, minus 14, minus 16, minus 18 and so on. If A equal to 15 and D equal to 0. So 15 starting number. Next no difference. So 0 no 15 minus 0 15, 15, 15 and so on. So this is also an AP. Suppose A equal to 5 and D equal to 1. So it's a positive. So A equal to 5, then addition 1, then after that 1, 7, then 8, then 9, then 10 and so on. So such type of AP is that. So we studied A, A plus D, A plus 2D, A plus 3D and so on. This is the last number. Now we are going to study nth term by using this general form. Already we studied A plus D, A plus 2D, A plus 3D and so on. Using the number first term, second term, first, second, third, fourth and so on. Here I am going to use this thing A, A plus, second term no, so 2 minus 1 into D. Third term no, so A plus, third minus 3 minus 1 into D. So here A plus 4 minus 1 into D. Fourth term. Similarly, nth term, A plus, instead of number, here you have n. So why this nth term? This is in AP. Okay. Now we need to find the last term of the AP. It's a finite arithmetic progress means last term we need to find. So suppose 5, 10, 15, 20 and 2. Here suppose we have 100 terms. How many terms? 100 terms. Now 100 term means here n is 100. So that is A value 5 and D value equal to common difference 10 minus 5, 5. So now nth term A plus n minus 1 into D. The nth term means 100 term here equal to A plus A equal to 5 plus n 100 minus 1 common difference also 5. So 5 plus 99 into 5 equal to 99 into 5. 495. 5 plus 495 equal to 500. So in this AP, 100th term is on nth term is 100. So we need that idea. So here nth term a plus n minus 1 into d. We are going to give the name Tn. Why Tn? This one is term 1. Term 1. This is term 2. This is term 3. This is term 4 and so on. So that's why Tn indicate first place, second place, second term, second place, third term, third place, like that. You may think that one first number, this last number, so that we can write this one also L. So here the name of the term is Tn equal to R. We can write L equal to the same thing, a plus n minus 1 into d. This is the last term. So sequence we studied, arithmetic progress we studied, and the nth term also we studied here. Now which one is AP and which one is not AP also you studied, right? Now think about the series, think about the sequence, that is arithmetic progress. If nth term given, then how to find the AP? Is the question. Nth term means last term. So last term means 5, 10, 15 up to 100. Now directly given 100 L. If this one given, that is 100, 95, 90, 85. Like that we need to find this answer, this AP. First, if A is given, D is given means how to find AP and how to check whether it's AP or not by using D. Next, if last term given, that is we are going to write this AP as last term given 100, 95, 90, 85 and so on. So first itself they are indicated. If A is, think about this is AP given, means A equal to 100 and D equal to 95 minus 100 is minus 5. No problem. Suppose it is given AP first term 100 and D is minus 5, decreasing, no? Right. Suppose last term is 100 and D is given. Now how to find? D is 5 or minus 5, like that given. Now we need to find that thing. So nth term of an AP is given means that arithmetic progress general form. How to find? The general form is, that is L minus D. Definitely decreasing, no? Definitely we needed to decrease that positive D because it's last term. L minus 2D, L minus 3D and so on. This is the arithmetic progress. Okay. So here think about this one is given, like that decreasing. Now we need nth term. In the same way, we are going to find nth term. In that A, a plus d, a plus 2d. We have nth term Pn equal to a plus n minus 1 into d. Here we need to find the nth term of this sequence. Instead of a, you have first number l. Here you have positive d, positive d. So here nothing but decreasing, no? So a plus n minus 1 into a plus n minus 1 into, here think about the d, a plus of minus d, l plus of minus 2d, l plus of minus 3d, decreasing, that is minus. So here also minus. So Tn equal to l minus, we need to write here, into n minus 1 into d. Last number given means we can find that AP by using a plus n minus 1 d, but we need from last means l minus n minus 1 d. Now you can get the idea, because by using positive and negative, positive no, just increasing, negative no, just decreasing. This one is from left to right, like that you can think. This one is from right to left, you can think. Same AP not going to change, that is 5, 3, 6, 9, 12 and so on. Here 30. AP not going to change. The thing is, here you have A equal to 3 and D equal to 6 minus 3, 9 minus 6, so D also 3. Here L equal to 30, but the difference is decreasing now. Here from last term we need to find. So 30, previous term definitely 27, that means we are decreasing now. So D equal to minus 3, that's all. From this we need to find, means use a plus n minus 1 into d. From the last end we need to find, means use l minus n minus 1 into d, that's all. So that is here. For this use a plus or Tn equal to a plus n minus 1 into d. Here for this Tn equal, from this point it's a last number, from this point this is a last number. So L plus minus n minus 1 into d, that's all. So AP never going to change. Your view from first term to last term, from last term to first term. So further 3, 6, 9 like that also we can write, and 30, 27, 24 like that you can write up to 3. So for that, suppose you have a last number, your answer is 3. Further here your answer is 30, like that. Okay. Right. So here I am given all the chapter formulas. So here you have L equal to a plus a minus 1 into d. If last term given, then finding AP is Tn a minus n minus 1 into d. That's all. Right. Now sum of A, summation of A. Okay. Now we are going to use this general form. So general form only we are going to use. So for the sum of AP, what are the term we discussed? Sequence from this AP, from this nth term, and finally by the last term, and now we are going to sum of AP. Sum of first n term, right, n term. So Let the AP be general A plus B, A plus 2D, A plus 3D, and so on. Here last term A plus n minus 1 into D. Previous term A plus n minus 2 into D. That's all. Now reverse the arithmetic. That is here S equal to summation. We are going to use this on AP. Let summation S equal to A plus D plus A plus 2D plus A plus 3D plus up to plus A plus n minus 2 into D plus A plus n minus 1 into D. Okay. Now reverse the AP. So first term no A plus n minus 1 into D, comma A plus n minus 2 into D, comma up to plus last two terms A plus D, A. Reverse. So this sum, therefore S equal to summation A plus n minus 1 into D plus A plus n minus 2 into D plus and so on plus A plus D plus D. Now add these two summation because we need to find the sum of AP. Further do this process. First write the AP general form, write the addition. Reverse the AP, write the addition. Let it be first equation, let it be second equation. Add 1 and 2. So left side S and S. So S plus S equal to our normal addition. A, here A plus n minus 1 into D. A. So 2A plus n minus 1 into D. Next A plus D, A plus n minus 1 into D. Think about A plus D plus A plus n minus 1 into D. This addition we need to write here. A and A we can write directly as 2A. D n minus 1 into D. D is common, no? D is common. Then what things we need to write here? You have 1. So 1 plus n minus 1. Common D. You can cancel D. So 2A plus n into D. 2A plus n minus 1 because here n minus 2 no sorry. So n minus 1 into D. So here also 2A plus n minus 1 into D. Then come to last A plus n minus 1 and n minus 2D, A plus D. A plus A, that is A plus n minus 2 into D plus A plus D. Addition. Addition of these two numbers. So A and A like that. So 2A. Here D is common now for this. So D into here n minus 2, here your number 1. So 2A plus n minus 1 into D. Same thing. A plus n minus 1 into D. Next, A plus n minus 1 into D. A addition is plus A plus C 2A into n minus 1 into D. this one. Now think about s plus s, we can write 2s. Here how many such terms we written? N terms. First term, second term, third term, fourth term, fifth term, sixth term, like that. Here n term. So here totally how many terms? N terms. Okay. Now suppose just think about 3 plus 3 plus 3 plus 3. How many 3? 4 3. So we can write 4 into 3. That answer is 12. Addition also 12. Suppose 2 plus 2 plus 2 plus 2 plus 2. How many 5? 5 2's. So 5 2's are 10. This answer is 10. Similarly, 2 plus 2 plus 2 plus 2 plus 2 plus 2 plus up to plus 2. How many 2? 52's are there. 52's. What is one? 1 2 3 4 5 6 up to fifth term. Now addition we need to find. So directly we can write 50 into 2. That answer summation is 50 into 2, 100. So like that. Here we have n terms. So for that just you can write n into 2a plus n minus 1 term, 2a plus n minus 1 term. So repeated. So 2a plus n minus 1 into 2. Now we need only s equal to n divided this 2 we can write as divided by 2 into 2a plus n minus 1 into 2. So now this is what sum of first n terms of AP. Suppose you are going to write s equal to n by 2. You are going to split to a 2a as a plus a, 2a as a plus a plus n minus 1 into d. Think about this one. A plus n minus 1 into d is the last number. So n by 2 into a plus this one last number. So here. So this one also we can write. But if you have last number and the first number and the nth number means we can write yes. Or n and d if you know that means we can use this formula. Right. So using this we can find the sum of first n terms. Now I just once again give you the idea of the addition. Suppose is equal to this thing. First one a plus d plus a plus 2d plus and so on, a plus n minus 2 into d plus a plus n minus 1 into d. Next the same s equal to reversing this. A plus n minus 1 into d plus a plus n minus 2 into d plus a plus n minus 3 into d plus and so on plus a plus b plus a. This summation we need s plus a. So add these two numbers. No, so for that actually the process over and just repeated the addition. You may think the addition is somewhat difficult. So add these two numbers. So s plus s equal to here a plus first a plus n minus 1 into d first over plus this a plus b plus a plus n minus 2 into d second over, then come to last, no need to write this, then this plus 2 plus a plus n minus 2 into d plus a plus d, then write this one plus a plus n minus 1 into d plus a. Now first one no problem, a plus a, so 2a plus n minus 1 into d. Here you can write a plus a as 2a, a plus d. Here you can write n into d minus 2d plus up to plus a plus split to our bracket as n into d minus 2d plus a plus d. We can write this a plus a as 2a. Similarly here plus a plus a plus a 2a plus n minus 1 into d. Right. First thing no problem, 2a plus n minus 1 into d. Right. Here 2a plus here d minus d. So we can write d minus d as 2a plus d, no. So n into d minus 1 minus 2 minus 1, so minus d plus and so on plus 2a plus nd and minus 1 minus d minus 2 plus 1. Here no problem, right directly plus 2a plus n minus 1 into d. That is 2a plus n minus 1 into d, no problem. Here 2a plus d is common, no. So n minus 1 into d. D is a common. Plus up to for this 2a plus d common. Here you have n minus 1, so minus 1. This is no problem. 2a plus n minus 1 into d. Now first, second, third, fourth, fifth up to n. So that n times. So 2a is equal to n into 2a plus n minus 1 into d. So therefore s is equal to n by 2 into 2a plus n minus 1 into d. So like that we can write. So summation we can think first write and reverse write, and finally you can write s plus s equal to this 2a plus n minus 1 into d plus 2a plus n minus 1 into d plus 2a plus n minus up to 2a plus n times. You can write this step addition. After that you can write this. Then you can study n into this thing. So this is the things are given in your arithmetic problems. So using this we are going to discussion of the problems. Suppose example 1 given 5 1 by 2, 6 1 by 2, 7 1 by 2 and so on. It's AP given like that. Then what is for A and what is for B? Means A equal to first number, therefore A equal to 5. D we need to find. D equal to 5 1 by 2 minus 5, that is 1 by 2. So D equal to 1 by 2. So check 5 1 by 2 minus 5 equal to 1 by 2, comma 6 minus 5 1 by 2 equal to 1 by 2, comma 6 1 by 2, comma 6 equal to 1 by 2. Okay, this thing. So like that you can write first term and last term. And the next, first one write A and B if it's AP. Second one, so given series is AP or not, given sequence AP or not, how to check. Here the numbers it may be given 6 8 10 12 and so on. A equal to 6, no problem. D we need to find. So for that 8 minus 6 2, 10 minus 8 2, 12 minus 10 equal to 2. You think about only the given numbers, don't bother about the unknown numbers. We need to consider the series like that, so sequence like that. Here the difference is common, no, 2. So that is D equal to 2. Therefore it is AP. Okay. Suppose the problem like that. Now a equal to 6, okay, but 9 minus 6 equal to 3, 12 minus 9 equal to 3, 13 minus 12 equal to 1. There is no common difference now. So therefore it is not AP. This is not arithmetic progress form. This is not in the form of AP. So if A given and D equal to 3 like that given, therefore AP 5, next number 5 plus 3 8, next number 8 plus 3 11, next number, like that you can write it. Okay. So this is an introduction session of your arithmetic progress and also the introduction session of your formula. The things are studied: sequence and arithmetic progress. In that arithmetic progress, finite, infinite or constant arithmetic progress, that is by using decreasing, increasing and also no change. After that you studied general form of the arithmetic progress. By using general form, nth term of arithmetic progress is a plus n minus 1 into d. And finally we studied from last how to write the arithmetic progress, a minus n minus 1 into d. From last we can write. And finally sum of nth term also we given here, and using this examples we need to solve. Thank you.